Oh man, this guy's upstairs. I don't know what these guys are doing. Sorry about that. Hello, everyone.
Hi, everybody.
Christian, hey, SJ, how's it going, guys?
I'm fine, man. Thanks.
Awesome. So, where are you nowadays, SJ? SJ?
I'm in the Netherlands now.
You're a lucky guy. You get to go everywhere, huh? Every week, every other week.
Tomorrow I go to France and then after that to Spain.
We
And
envy
then
you, SJ.
and then probably all the way up to Sweden again.
Nice.
So I tried to talk with this Rick Valkvinger from the Pirate Party, and he's a specialist in swarm technology,
Uh-huh.
in swarm communities, how to set it up and so, and to make it a worldwide movement, which is necessary for rolling. Yeah.
Right, Chief?
So
So, HJ, so you're talking to Rick again. How did you contact him? Did you just contact him by email?
yeah, I have to contact him still. But probably it's by email, yeah.
Cool, because it'd be really cool to get him on an interview. Because when after I uploaded that video we did in Amsterdam, a lot of people were asking, like for another one because he's like really people want to hear him. So, it'd be cool to hear more of him.
He's definitely interesting. And I think this whole network about Rolang and so could be very interesting for him also. Because that's with this pirate party stuff. So you need an unstoppable system that cannot be reviewed by central parties. So that's an excellent case for him.
Who is this, HJ?
That's the leader of the pirate party in Sweden.
Oh, yeah. Got it.
And they claim privacy for everybody.
Nice.
And they also say, well, the whole music industry is not free enough. So you should be able to download for free or so, or for at least for a fee that returns to the artist and not to the third parties. So, and he has written a book about how to organize things in a massive way. And they managed in Sweden to grow a party, a political party, for in half a year. And they had a seat in the European committee in the parliament. So that's amazing, you know, from a party who has no members, and then in half a year reaching such a big goal. So, and he has written down how to do that. And it's a very practical manual for also for communities like this.
Wow, that's great. I definitely would love. Let's definitely get him if he wants to come and join us for an interview. That'd be awesome.
Okay, I will tell him that. Yeah, thanks.
Yeah, that'd be really cool. I'm glad to see DC is here. He posted a question in the RChain Slack regarding the translation of pi calculus into Scala. And I will make the slides available. I've gone over them a few times in these Hangouts. I'm driving right now, but as soon as I'm back at my desk, I can walk people through that and also make the slide available. I took the last 2 days off. I needed it desperately. But I'm back in the saddle today. Looking forward to responding to questions and getting this stuff underway. it's actually quite straightforward. If you have if you think of the namespace as a giant hash table, and the keys are the names, and what you can store is either some data or a continuation. Then when you go to put a value at a key, you have to check and see if there's something already stored there. And if you're about to put some data, if there's a continuation there, you hand the data to the continuation and you remove the key pair. If you're about to put a continuation there and there's some data there, you hand the data to the continuation and you remove the key pair. That's the core semantics. Right. And that's easy enough to write down in Scala.
Yeah, Greg, I saw the for comprehension structure, and I was looking at that structure in the code base, you know, on GitHub. And I was looking at how you're using the reset blocks to wrap that logic. I just if it's, you know, I just thought if it was easier, it'd be informative to be able to see that slide, because there was some other translation of some of the other parts of the calculator it looked like, and I just wanted to, I mean, I could probably infer what those Scala expressions look like.
Yeah, I'll put it up there. I just wanted to let you know I don't normally like to let questions like that go for too long. I was just on vacation, and I thought I'd give you just a quick explanation of what the Scala code does. What the nice thing about that particular semantics is that it has all these pleasant sort of side effects. It has all these pleasant knock-on consequences of that choice that I've mentioned before many times. So in particular, you can make decisions about when you hand the data to the continuation, whether either or both persist. And if they persist, if they both persist, then what you do. And the main point about the use of delimited continuations in this particular semantics is that it makes it easy to capture kind of the most localized continuation. It's still in the Scala implementation of delimited continuations. It's still somewhat complex because, as you can see with the special K code base, we capture a lot more scope. But that's where that's one of the principal reasons we're moving to RChain, is that we have we want to be able to limit the amount of scope we capture at the moment of grabbing the continuation. Does that make sense? Do you understand what I'm saying?
Yes, I do. But by moving to RChain, you mean because you've got at the moment, you know, several different components, haven't you, under the scenario library there?
Can you say that again? I couldn't hear you.
What do you mean by moving to RChain?
Right. So essentially, you can think of the RChain platform as a rewrite of the salient features of Special K, so that we incorporate, such that we can incorporate the blockchain semantics, right? So, you know, you take Special K, you add Casper to it, and you get a blockchain that's scalable and has a lot of other nice properties in it.
Right. Okay.
Right. And so then whatever you put on top of Special K, whatever application, whether it's social network application or a jobs application or a dating site or whatever, that should, you know, largely speaking, remain, you know, architecturally what it was, especially if the application made use of the reactive media design pattern that I laid out a couple of years ago. So if that design pattern is the sort of the thing that's underlying the architecture for those applications, then when you move those applications over to the new back end, it's not a giant port.
So RChain will incorporate the storage elements from Special K, but it's going to incorporate all of the same characteristics as Special K.
Yeah, it'll be slightly refactored and repackaged, but all the features that you find in Special K you'll find in one shape or form in RChain. Actually, it'll be more than that because we have the virtual, because we own the virtual machine, right? And because we own the virtual machine, the way we do delimited continuations is different. And because we own the virtual machine, the state that we're storing is different, and so on and so forth. There's also there's a recursive nature to this that makes it harder to talk about, right? Because how do I say this? The storage depends on RChain and or the new Special K semantics, and the new Special K semantics depends upon the storage. So there's a core piece of it that is at the bottom of that recursion, and then you build more and more functionality on top of that. Does that make sense? Yes.
So you can't really separate the characteristics of the storage layer from the way that you from the structure of the calculus, right? The four comprehensions and the continuation.
That's exactly right, and I think that, to me, that's a significant advantage. And the reason it's an advantage is because it gives a search model that is much more sophisticated than what we currently have with the blockchain. Mm-hmm. Right? There's a whole query language that's associated with the storage mechanism that is the blockchain. So it's not just about querying addresses or, you know, querying some ad hoc structure.
Right.
Yeah.
And it's very elegant, but it takes a little while to appreciate that, you know, to appreciate just how related all those parts of the system are. I guess it's the compositionality being, you know, because it's falling out of that, isn't it? You know, the fact
that's exactly right. Yes, and that's why it's really, really hard to get across occasionally. You know, how all the pieces fit together in this, you know, carefully constructed way.
But I think at the same time, I think people who've been working in developing distributed applications and distributed computing have the fundamental knowledge of concurrency and of dynamicism and of reactive code thereof. So it's kind of interesting that people who've been waiting for a structure to support. That wasn't me, was it?
No, dude. That was horrible. Okay, so Greg, there's two Gregs now, and there was feedback, so you caught all the feedback from that for some reason. So maybe you should just repeat.
I didn't know if you were kicking me off the platform.
No.
If I had reached my limit, your time here is done.
No.
No, I didn't hit the mute button fast enough, and the feedback caught me and everyone else by surprise. Sorry about that.
Gotcha. Developers who've been looking for a platform to build actual distributed applications will appreciate this because of built-in concurrency. You know what I mean? If as opposed to one that isn't concurrent, or a blockchain that isn't concurrent, isn't composable, it's kind of inconsistent if you don't use a blockchain that's concurrent and composable for concurrent dynamic distributed applications. You know what I mean? So at the same time, it's like a layer of security that people who have been trying to build these types of applications have been waiting for.
Yeah, I mean, that's what I've been trying to say for a long time, is that you have to have a programming model along with all the other features.
Yes. Yeah.
And that's sort of why the mobile process calculator is so important, because they tie the features together and provide a programming model. And in some sense, that's what Rolang is evincing, right? Here's a programming language that comes along with a sort of clear programming model, and fits together with all these features in this nice way. I don't know if people followed, but with respect to this, so how do I explain this? We're going to need both a wire format and a storage format. And that's important because we need to be able to ship contracts around. We need to be able to ship contracts in a particular state around. And so we need to be able to ship those across the wire, but also get them to store and from store. Often it's the case that, if you have a really finely tuned application, those end up being different. So the wire format and the storage format are different. In today's environment, people are pretty lax about those kinds of efficiencies, so they end up collapsing. So people will make JSON the storage format and the wire format, as an example. I'll just say personally, I think that that's not an ideal situation, because JSON is inefficient, and provably so. If you're going to keep the JSON semantics as it is, where you have where things can come in any order, safe parsing of JSON where things can come in any order means the complexity of your parser is much greater than it has to be. If you fix the order of things in structures, if you fix the order of data in structures, then safe parsing of those structures, i.e. parsing of structures that match a particular upfront type description of the structure you're expecting, is much, much more efficient. However, not everyone, feels that that's important. For those of us who feel that typing is important and that kind of safety is important, then JSON is less efficient. However, there's a nice halfway house, which is, it turns out you can give a direct encoding of JSON-like data structures into the syntax of the Rolang itself. And for the time being, I will be fast and loose with my language, and say that Rolang and the row calculus are the same. The reality is, you think of the row calculus is to Rolang as lambda calculus is to, say, Haskell. Something like that, or System F is to Haskell. That's probably the more accurate thing to say. In the storage sub-channel on the RChain Slack channel, I gave a sketch of the encoding. And what that means is that we have, in Rolang, we can have a format that works just like the JSON format does for JavaScript, in the sense that you can write out data representations directly in the syntax, which means you can push it across the wire that way, and you can push it to store that way. And on top of that, there's a nice translation to JSON. So if JSON is coming into the system, we can convert it to that format. If we want to push data out to a system that expects JSON, we can convert it to that format. Is that making sense? Do people understand what I'm droning on.
Yeah, I
Yeah.
saw your comment in the storage channel, and it was I was struggling actually with visualizing how, like, you could serialize processes to something like JSON, where you've got, you're dealing with two category. The data type is I was struggling to visualize how you could simplify down to JSON,
Yeah, yeah. So let me describe that for you. I'm going to do just a quick screen share, and so that people can see what that's. And I hope people don't mind if we have kind of a more focused technical discussion, because this is what makes me happy.
There was actually a set in Greg. Didn't you first mention this, or early on in your namespace paper, like validating the structure of data? It's like we can it like gives an outline of what a useful namespace looks like, and being able to quote the data structure as a name and pass it around exactly as you're talking about.
Yeah, that's exactly right. So what I showed was that we could do a core of XML.
Yes. Yeah.
Using the namespace structure, and so essentially this is building upon that idea. So just to get things set up, in programming language semantics, the kind of the double braces is the meaning of function. So think of it as translate from, right? So we have some function which is going to go from, well, let's say here we'll go from JSON into row. So I'll just write it like that. Okay, so we have a function that does that. And then, we could also talk about the inverse of that function. So, which would go from some subset of row into JSON. Okay, so that's essentially what we're about. And the argument to the function goes between the curly braces, and what squirts out of the function is what it produces. Does that make sense syntactically? Are people following along?
Yeah, yeah.
Okay, awesome. So then the sort of standard JSON object looks like this. You'll have open squirrely braces, and then you have a key, and then there's a colon, and then you have a value, right? And there might be lots of these. Cool, there's that. And so there's that, and notice that really this is part of a recursive spec, and the recursive spec looks like this. JSON object is of the form, and then these are going to be, these values here are really JSON val, right? And then a JSON val, just for purposes of discussion, is going to be either a ground value. How about we'll do it JSON ground, or it's going to be a JSON obj, right? And then we just said what a JSON obj is, so we only need to say what a JSON ground is. And that might be, let's say, either a Boolean or a string or a float, sorry, or an int or a float. Okay, so that's roughly speaking, that's the data type that is described by JSON, right? We've just given concrete syntax for that data type. And so all we have to do then is we have to give a recursive function, i.e. the double braces one, which walks over those structures and produces some row calculus syntax. And that's really not very hard at all, actually. If we, so what we're looking for is the recursive specification of this thing, which is just going to be, well, we're gonna, if I use the row-lang syntax, then squirrely braces is actually perfectly reasonable row-lang syntax, right? And now what we're gonna use for our keys is we're gonna use names, right? So we're going to assume a polymorphic form of the double brackets, which knows how to turn keys into names. So we recurse on the key producing a name, right? That's what this thing produces.
That's like packaging it up.
Yeah, exactly. And then instead of the colon, we're going to output. And what are we going to output? Well, we're going to output the JSON val, which is sitting there. Now notice that this is a grammatical production for the entire type. This should be a value. So here, I'll go back to the value 1 here and value n here. Right. So that's the type versus token distinction. Right. So now I want to translate that value. Right. I just recursively call my translation function. And since by definition, none of these are ordered, right, in a JSON object, they're by name as opposed to by position, then we get to just do a parallel composition here to preserve perfectly the unordered semantics, right? And then if you will permit me, I'll just do a cut and paste, and there's that, and there's that, and there's that. Cool. So that's the translation for that. And so the only thing left, of course, is to say how we translate Boolean, string, int, and float. Now, if we're using the full row lang as opposed to the row calculus, then we have at our disposal strings, bools, float, and all of that, right? So the translation is the identity, right? The recursive translation on the ground values is just the identity, right? Does that make sense?
Cool.
So we are with one line, we have now given a clearly correct by construction translation in this direction, right? So this is the direction we just did, the top line. So how would we do the reverse direction? Well, it's not particularly hard, right?
Right.
So
yeah, I got that. Logically, how the JSON types could translate. You could superimpose something onto that kind of structure. I guess I'm familiar with all of the, I'm really familiar with all the JSON types, so I understand that part of it. I guess I was trying to project. I'm less familiar with, with Rolang. Yeah. So I was wondering about how, keys and values, and the functions and processes would behave, because the key in this case could be a quoted process.
Well, they're in special K, they're prolog terms, right? So they would be atoms, values, variables, expressions.
Right. Okay.
Yeah.
So I'm mixing up the pi calculus with Rolang in that case.
No, I think all no, that's all very good observations. I think if we're super careful, we have then yeah, keeping all of that hygienic and clean is actually a really good thing. So what you're bringing up is not bad at all. So let's take a look at that and see, what so there are actually three different things that we might be talking about, right? One is the pi calculus, and another is the applied pi calculus, and another is the row calculus. Now it turns out we're in luck, and the reason we're in luck is you can write down the pi calculus as parametric in a set of names. So you can say the pi calculus is really given by this recursive equation that's a lot like these grammars here, right? So we say, you know, a process is, but the pi calculus is really, if you're very careful about it, what you really are providing is a data type that is parametric in a set of names. So you have P is of the form, and P of X is of the form, well, it's the stopped process, or it's an input guarded process, so it's an X, right? And so this would be for an X from an X. And then what do you do with it? Well, then you can become a P of X, right? So there's the input guard, and then and this is just slightly different syntax than Milner's syntax, right? I'm writing the syntax to be more programmer friendly, but I have all the same data elements, right? And then I have an X, and outputting in the pi calculus, you have an X, okay? And that's kind of important, right? Because it's not higher order like the lambda calculus is. And then you can do the parallel composition of a P of X in parallel. And I'm going to put the vertical bar right between them so we don't confuse it with the vertical bar that means choice. P of X. And there's other stuff for recursion and so on. But this is the core of the pi calculus. Okay. Now it turns out if you you can fill in this recursive equation. If you fill that recursive equation in with Prolog terms, then you get the applied pi calculus. So set X to be Prolog terms, then you get applied pi calculus. And if you set X to be quoted processes, then you get the row calculus. So that turns out to be super useful, right? Because it allows us to just have one structure that we're reasoning about, and we get lots of different flavors. And that's how special K is related to Rolang.
Well, it seems like throughout history, there's kind of been this. So I mean, and especially in programming languages, I mean, there's always like someone's always pushing like how to meet the next layer, the next level of abstraction, right? Like in C++, you'd say the greatest level of abstraction would be like template metaprogramming in C++. Moving out to like Haskell, to Scala, we developed ways to look at or represent like mathematical structures and kind of abstract ideas in a functional language. And in Special K and in what will eventually be Rolang, taking entire terms, entire data structures, evaluations, abstracting them to a single representative entity, forgetting about them, and then just worrying about the interface after, which is, I mean, it's really cool and especially useful given that it's like, I mean, building on the idea that processes, functions are all objects, and that once you implement them, you only have to worry about the interface with them.
Yeah. So it's but remember, the notion of interface changes in the logic as a distributive law world. The notion of interface in Haskell and Scala what it says is it looks at what goes in and what comes out. What it doesn't look at is substitutability in terms of other kinds of observable behavior. So the question is, both viewpoints can be unified if you look at it from the perspective of what's observable. And as long as you're clear about you're clear about what constitutes your observables, then the two viewpoints are the same. However, what's observable in terms of the kind of typing disciplines that we normally see in functional programming languages is really, the stuff goes into a black box and comes out of the black box. But we are with the behavioral types and the spatial types, we can see a lot more. We can kind of have X-ray vision into the shape of the black box, so it becomes kind of a white box. And on top of that, we can see more about how the cogs and wheels are turning inside that box. And so so both notions of interface govern substitutability, but the latter notion of interface is more like being able to so the analogy I gave at DevCon was, think about the difference between a wire and plugging in a chip on a board, right? So when you're talking about the wire, you're only concerned with either end, what goes in on one end and comes out on the other, and vice versa. Whereas with the chip, you really are concerned, like if you plug in memory where you're expecting a processing unit, the whole device that's being sketched out on the motherboard is not going to function properly. So there are more constraints than just what's happening at the pins where the chip attaches to the board, right? It's a lot more about the overall behavior of that little component that you're plugging into that slot. That's the notion of substitutability that we have when we go to namespaces.
It's about logic.
What's that?
It's about logic. Whatever you substitute the processes or the memory spaces, right?
Yeah, that's correct. You get more of a view, and it's not just about the behavior. You also have this view into the structure. So kind of the point I was making, though, to tie this all together is that Rolang kind of for free gets a storage notation that can be utilized on the wire and on disk or on persistent store, that has the property that it can easily be converted into standard formats.
Nice.
Right? We can easily we can reason about how to turn it into JSON, and so that Rolang contracts can communicate with programs that take in JSON and spit out JSON. So that means we have good, we play nicely with others, and it fits well with our correctness proofs, right?
Right, so they don't get interfere with one another.
Yeah, exactly.
They're in the same memory, in the same state, and if they share the same state, we are bound to interfere, some weird cases.
Yes, yeah, that correct. We're able to construct proofs about interference, and that's important. So let's see. It looks like maybe there are other folks. There's stuff in the chat. Let's take a look. It looks like Ian wanted to clarify. So right now we don't have clarity on the relationship between Scenario and RChain. We had been hoping that there would be very clear relationships, right? So what we sketched out in the architecture document was that there was going to be a that essentially RChain was going to be, essentially a part of Scenario. And eventually we would put a nonprofit foundation around that. We started looking at, the shape of that nonprofit foundation, and I've been very attracted to the notion of a co-op, and I'm still very attracted to that. What's made things less clear is that we don't have a good, there hasn't been a good resolution between Dora and myself on how to go forward in terms of our working relationship. So there are three outcomes that I can see. One is more or less the same as what we started out with, which is that there's an RChain sub-project of Scenario that eventually gets a nonprofit organization spun up around it. So that's one possible outcome. Another is that RChain is formed, and the relationship of sort of being a sub-project of Scenario is no longer the case, and there's a kind of informal business partnership between the two organizations. And then the final possibility is that there's just no relationship between them at all. And so what we're trying to do is to sort through those different relationships and see what makes the most sense in terms of preserving the value built up and the communities built up. As near as I can tell, in all three situations, RChain is formed because that's currently the technology that we're betting on in order to get to market with Scenario. So therefore, it makes the most sense to proceed as we had thought we would to get this underway. It's also really important to understand that if you look carefully at the balance of things that need to be developed, what we're talking about here is the development of a new programming language, right? So that's on the order of developing something like Java. That's a big thing, and probably as big. If we do it right, it's as big as Facebook itself, right? Just in the same way that the C programming language was at least as big as Facebook was, because there are lots and lots of applications written in C, and hopefully, if we do this right, there will be lots and lots of applications written in Erlang.
But once the bare bones exists, people can start writing applications and modernize as it's updated, correct?
Oh yeah. I'm just trying to kind of list out, when we talk about RChain, what are we talking about? Well, we're talking about the Erlang programming language. We're talking about a variant of the Casper consensus algorithm, which in itself is already a giant thing, right? It's as big as proof of work, and we're talking about a blockchain mechanism that utilizes that replication or consensus algorithm, but also has a storage mechanism, right? So essentially, we're talking about a replicated database that's decentralized. In addition to that, we're talking about a query language that sits, or query semantics that sits above that. We're talking about a virtual machine that the state of which is on top of that, and we're talking about a programming language. And that programming language has new features in the sense that it has this behavioral types, which in and of themselves constitute a major development in computer science and industry. So that's the feature set for RChain. So it's all cool, it's exciting, but when we compare that to the feature sets that we are talking about for Scenario, like apart from the reactive media design pattern, which I sketched out 2 years ago, the other things that are being considered for Scenario are not new or exciting, right? If we were talking about what constitutes where we should put our resources. Which is not to say that, you know, scenario is not exciting. Scenario is very exciting. It's a very important application. But when we're talking about adding groups or adding threading on a message chain, it's not, those are not features that we want to have the same kind of, it doesn't require the same kind of development effort. It doesn't.
Okay.
Yeah.
Yeah. So yeah, I definitely appreciate the size and the ambition around RChain, and it's going to be awesome. But I want to be careful about the language about what scenario sort of was to people in terms of the scope and how you just used it. You were contrasting scenario with RChain as if it were separate than RChain and only the social product, if you will. But in the different alternatives that you were describing earlier, one is that scenario is essentially the superset of the social product and RChain, as opposed to completely distinct from it in feature set. So I just want to, you know, I think all along the language around scenario being many things that makes it ambiguous and hard to talk about. It's a company, an Israeli limited. It's a social platform, and over time it also became RChain as well. And so we're going to have to invent and clarify some new language, I think, around. I always use the word social product to talk about that aspect of scenario, and RChain could also be an aspect of scenario as well. So anyway, the language we have to be, I think, careful, otherwise we're going to cause additional confusion.
That'll be easier probably once the updated name of the social network is released.
Right. Exactly. and I think the scenario community hasn't been referring to it consistently to date. I mean, some people call it the alpha, which that's the closest clear name. I call it this you know, the social product alpha release. But anyway, the terminology Greg just used was to contrast scenario with RChain, and I think that assumes a particular organization that would be split, and I just want to caution us from concluding that prematurely.
So I didn't. Thank you very much for that clarification, Ed. I didn't actually intend what you heard, and so it's useful to. What I meant was the scenario social product.
Exactly. That's what I thought.
Yeah. So when we're talking about the social network as opposed to the company or some of the company's technical ambitions or product ambitions, the social network, when we look at its features and we ask about resourcing, well, the difference between designing, implementing, and delivering a general purpose programming language that has built-in blockchain capability is orders of magnitude more difficult than building groups in a you know, a social network, right? It's orders of magnitude more difficult than adding a venue, you know, a kind of or threading on the on a message chain. So
yeah, speaking like just personally, you know, I don't know whether it's useful, you know, but from my perspective, I was actually aware of scenario as a project for quite a long time, but I was completely disinterested in the project when my understanding of it was that it was a, you know, a social application. And I became a lot more interested when I discovered the ambition, you know, of the project from a technical point of view and what the underlying, you know, technical ambitions were. And I discovered that much later, you know, after listening to Greg, and all of a sudden the project, you know, that's when I really became interested, when I found out the ambitions in terms of RChain and the technology that was going into implementing the project, you know, the project. And that's just my personal, that's obviously not true for everyone, but yeah, changed the game for me when I discovered the scope of those ambitions. Yeah.
I think, first of all, thank you very much for saying that. But I think also that it's the case for others as well. I think it's not just yourself, but that's what we heard from many investors, was that what changed the game for them was essentially RChain. That said, on balance, I think for many investors, what changes the game for them is the attention economy. And there, I think we have to be super careful when we talk about resourcing. Right now, Rolang for me and RChain for me, with the exception of maybe one or two elements in Casper, but Rolang for me is largely engineering now. It's fun engineering, it's challenging engineering, but it's largely just a matter of gluing together pieces that I've implemented and re-implemented again and again and again over the last 20 years. The attention economy, as I understand it, is an R&D effort. There is no written down specification that is satisfactory. And I think we've been upfront about that. I think we've said very much where the challenges are for us, what's defined, what's not defined. I believe that over this past summer, I finally have a handle on how that gets done. And so it's a really interesting question as to how, if we look at the other two options that we're considering in the in this transition phase, how the attention economy gets delivered. I don't know how that happens.
Well, there's this, what's pulling the development of scenario of the attention economy is that it's included at all, because the application itself is very, it's a social network, right? And social network and blockchain has been approached before. So the idea is that if we don't achieve like a marketplace, a location, if we don't fill that market, then someone else will. So I think the time, it's a time dependent development thing, which puts pressure on including development at all. I mean, would it be I don't know, would it be crazy to suggest that we do Project 11 for the for the attention economy scenario itself? I don't know.
No, I don't know. See, this is, I mean? I think you're onto something really important here, and that's it's the way I've tried to run scenario all along. To the best of my ability to have any influence is in what's happening. And I don't think people share this vision. For me, if it belongs to the people, we go to the people and say, how do you want to do this? Right? Yeah. Here's our best ideas. If you really want to see this happen, like, this is way too big than just a few guys can do, right?
Have you guys ever heard of Lumio?
Yeah, of course. Yeah.
Would that be that'd be a way to poll a crowd, right? To get a consensus opinion.
I think if we can get skillful enough with Lumio, then it's a reasonable tool to consider. Absolutely. But I think all I'm trying to suggest is that, to rein in the discussion, right? If we, I would think that when we talk about planning and resourcing, if we look at the social network feature set, right? And we look at things like, groups, threading. What are some other things, Ed, that we might want to consider here?
Yeah, venues is an interesting one, and note of how much a post is shared, right? So there's this tension between privacy, where it's not that social if there's just two people, and discoverability within networks. And so venues is kind of the trade-off there. And then what's the equivalent to what you would do for sharing and commenting and liking.
I'll put the word wall, because we've developed the private language of venue, but I think other people might understand like the Facebook wall.
Okay, yes, that's fine.
Okay.
So those are types of features. Invitations to have people outside the network come in and join is a particular feature set that needs to be explored. But and then obviously on top of what the combination of wall and privacy and all the privacy protection features, and you can think of a lot of various social uploading content, obviously, playing content and so forth. But then it gets really, really interesting when you put on attention economy stuff on top of that.
Right. So I think, for this, I think, I'm just going to ask questions and kind of take the temperature in the room. So I'm going to put the attention economy here, because I think it's a separate effort. So this is essentially, and so this is sort of the core utility of amps and core utility of Rio. Okay, and then there's lots of stuff we can do with that. But I know how right now with the stochastic version of the concurrency model here to build this. I don't know how it would be done otherwise. Like in other words, I think this is the killer app for this thing. In particular, Rolang, I think is the killer app. The attention economy is the killer app for Rolang. And I think that if I just do shirt size of value propositions, right? So let me try this way. So here's kind of my rough take on value prop and market response. And I think based upon my interaction with investors and others, this is kind of the way I think about things. So if I were to be apportioning resources, I would apportion resources to this and to this, and I'd be really, really stingy about this stuff. That would be the way I'd go through it. But I don't know. I'm kind of open.
But the social networking feature is, isn't it kind of intertwined with the attention economy? I understand, or it's the implementation of the attention economy. How do we separate those?
Well, I can separate them easily, because I could easily spend $3 million working on threading in groups and a wall. No, without batting an eye, because I could spend lots and lots of money on making it look pretty, lots of eye candy, making sure that everything was rock solid and bulletproof and foolproof and that sort of thing, right? And that would eat up all of the crowdfunding. I could spend all the money on this and feel completely justified in that kind of budgeting. However, when I look at what I'm hearing from the community, I think that being really stingy about these, just getting bare bones implementations together, because everybody kind of has a basic idea of how this works. They might be surprised about, this quirk of the feature versus that quirk of the feature, but they're not going to be in general shocked if it works slightly differently, especially if we have carefully laid out a unifying principle, which I will call the reactive media design pattern. Right. So this, I believe, creates the bridge amongst all three things here. And that's what I was trying to do when I laid that out back in the summer of 2015.
Talking about the community, I just would like to say that yesterday we had a long meeting about the governance about this community.
Mm-hmm.
we have set up, we have appointed a few managers, and we will support all these three things that you sketched on the white paper there.
Oh, sweet. That's great. That's good.
So, yeah.
That's very good news. I think what I'm trying to do is to dive a little further and say, you know, when I go through my sort of back of the envelope calculations about how to devote my time and attention to this kind of stuff, this is really low in terms of value prop. This is high in terms of value prop. This is high in terms of value prop. This is R&D. This is engineering. So I would stack, you know, something like 2/3 of my chips here, right? You know, half of a third of my chips here and half of a third of my chips here, something like that. Or maybe, slightly less than 2/3 and beef this up and beef this up. That would be the way I would do it. But I'm open. I'm asking people their opinion. How do they feel about this sort of thing?
Yeah, so we have set up also a forum on Consider It, to think about these things. So all these propositions we can put there and into Lumio and other tools.
To me, the social network feature set feels like a bit more of a gamble, you know, whereas because it's more subjective and there's so many nuances, you know, there's so many possibilities, and you know, you could end up with, just like we have on the you know, current internet, you know, there's lots of different ways that social networks can be implemented and have been implemented.
Yeah.
But they're all implemented on a, you know, it's the platform where the real value is for me.
Yeah.
And in a way, you don't actually need to worry about, you know, the social network feature set could be implemented by anyone, and it could be implemented in lots of different ways. There could be lots of different flavors, but the real value, you know, is the platform, is the technology itself, right? The underlying layer. That's the way that.
Well, these are all valuable, and they become very synergistic when they're put together. To me, the you know, part of the question is what the sequence of building out a vision needs to be. You know, the attention economy, once it's realized and sitting on top of RChain in a social network, makes that social network feature set all that more valuable, because, you know, kind of a multiplicative effect, right? And a social network added to marketplaces, such as the case with LivelyGig, when it is decentralized and involves you know, cryptocurrencies, becomes all of a sudden very valuable. I mean, many companies now are trying to leverage the social networks, LinkedIn, Facebook, and others, for these kind of marketplace effects. You know, unfortunately, they're centralized, and you are the product in these marketplaces and in these social networks. But I don't think we should underestimate the value of social networks. It's just, it doesn't really become differentiated until there's an attention economy, until there's marketplaces built and other features around the social structure.
You know what, Ed, I tend to agree with you a lot. And here's the way I think about it. There's a piece of the attention economy that I easily would call platform, that could have lots of different faces to it, but it's kind of the core API it's the functionality that supports a programmer API against the attention economy that other applications can put a face to, right? So if we say that in addition to the attention economy, you know, core capabilities, there's also, you know, a sort of attention economy user experience, right? Then I think of everything down here as platform, and I think of everything up here as, you know, a face on that platform, an application, one thing that could be utilized. And I tend to agree that a heavy bet on the platform at this point is what I've heard consistently from investors, whether they're excited about attention economy or RChain. Everything I've heard from every single investor that is serious and puts their money where their mouth is on the platform part.
So Greg, the only word I would use is leverage. What defining feature do you need to build to give you the most leverage in doing anything? And like, to me, just based off like the very visual representation of stars on a white piece of paper, it seems to me that you need to go into a direction that gives you like to the left there. Like you then you build that. Okay, now you have enormous amount of leverage to move forward in like pretty much any direction. Like what? Like one word, guys, leverage. Think about it.
To me, that's the way I'm thinking about this. But I'm wide open, and I absolutely hear Ed when he says that these things become enabling, and so I very much agree. I'm just trying to sort of make sure that we're all educated. I'm 5 minutes late for Dev stand up, so I should ring off. But I really appreciate the conversation, and hopefully this has been helpful for Ian and others, who are wondering about the relationships and the thinking that's going on. And again, I've tried to be super transparent. I know that other people in the process may not want this kind of transparency, but to me, it's really important. And I don't think that it has to be fraught with emotion or anything. I think it's actually better if we have more brains thinking about this stuff in a kind of dispassionate and engineering fashion, right? It's like, how are we going to get the most bang for buck here? I think that would be, and
I think we should ditch OmniLayer and concentrate on RChain, if you don't mind, Greg.
Sure, that's a very reasonable approach. Absolutely.
So I say we just give it a week. Let's start working on either a Lumio discussion or just break these things down into clearer points and move forward. And we can come back on the drawing board in a week, I guess, right? It never really stops, right?
Yeah, I agree. Okay, guys, I'm going to jump on to the other hangout now.
Later, Greg.
All right, cheers later on.
Hey, Christian, is this